Sorry, John, I don't know. I must have just hit stop for that video. I didn't mean to. So we were completing Pascal's triangle, and you can see that this pattern will continue and this pyramid will just keep on growing. And the reason why this is so important is because if you take a look at the page that we just did before, you see how we have, if you take a look at the coefficients in front of all of these terms, we have a 1, then we have a 1, 1, then we have a 1, 2, 1, 1, 3, 3, 1. Let's take a look. 1, 1, 1, 1, 2, 1, 1, 3, 3, 1. It's exactly the same pattern that we were seeing when we were expanding out these terms and rewriting them. So Pascal's triangle actually is going to tell us what our coefficients are going to be. If we take a plus b and we raise it to the 0 power, that's what we're going to get. If we take a plus b and we raise it to the first power, those are going to be our coefficients, and so on. But it is going to be just a little bit difficult. Let's just say we have a term and we're raising it to like the 37th power, and that's pretty dramatic or drastic. But if we were raising it to the 37th power, we would have to continue on and do Pascal's triangle that many times. So there must be a different way that we could figure out what the coefficients of the term are in front of those terms. So another kind of cool thing about Pascal's triangle is that Pascal's triangle is actually based on combinations. When I say combinations, I mean the combinations that we were just doing in the previous video, NCR, the button on your calculator that you know. So combinations, that first row, or that first top of the pyramid that was equal to 1, that's actually 0, C, 0, or 0, choose 0. And you could check that out on your calculator if you want to type it in. 0, choose 0 is equal to a 1. And then the rest of it is 1, choose 0, 1, choose 1, 2, choose 0, 2, choose 1, 2, choose 2. So you can see that there's actually a pattern. And if I did all this out, it would be the exact same thing as Pascal's triangle. So luckily, there is a way for us to figure out what the terms are in front, or the coefficients are in front of our terms if we want to expand it, and we don't have to just keep on continuing down for Pascal's triangle. So it's just kind of a cool thing to notice. So let's go ahead and we're just going to expand this term, m plus 2 raised to the 3rd power. And there's a reason why we're going to do that. Is because we're going to write it out, and then I'm going to show you all of the patterns that you can actually see in there. So write it out 3 times. And then these first two, if I FOIL them together, it's going to be m squared plus, this is going to give me 2m and another 2m, so that's going to be 4m plus 4. Now let's take that and multiply it by the last one, m plus 2. And let's see what we're going to get. M squared plus times m is m cubed plus 2m squared. Now I'm going to do 4 times m, which is 4m squared, plus 4 times m gives me 8m, plus 4 times m is another 4m, plus 8, and then we can go ahead and we can combine all of our like terms. Let's see. M to the 3rd plus, and then I can combine these. There's 6m squared plus 8 plus 4 gives me 12m plus 8. And another cool thing that you can realize or look at when you're looking at these terms is that the thing that's raised to the power, the m right here, it actually is decreasing in the exponents every time. This is m to the 3rd, then it's m squared, then it's m, and then this is actually m raised to the 0 power, because m raised to the 0 power is just 1. So that's another pattern that you can notice. So we're going to try to put together all of these patterns that we've kind of thought about and write it out. Where was it? Where did it go? Hold on. It's around here somewhere. In this pattern that we have. And the pattern that we have is around here somewhere. I swear I saw it. Really? Sorry, John, 1 second. Alright, I'll use this to explain the pattern to you. What we're going to do, if you are raising something to the 4th power, you are going to have 5 terms when you finish this off. So 1, 2, 3, 4, 5. Now, if there is a subtraction sign in between, you're going to make the first term positive, the second term negative, and it's going to switch on and off every single time. Plus, minus, plus, minus, plus. Okay? If it was a plus sign in between there, you would make all of those positive. But the minus means that the signs are going to flip every single time. Now, we were talking about Pascal's triangle and about how Pascal's triangle is actually a combination of a bunch, or it's just like composed of a bunch of combinations. So we have an exponent right here that's a 4. So what we're going to do is we're going to start out, we have a total of 4, and we're going to choose 0 of them. And then that's going to indicate what our coefficient is for that first term. Then we're going to keep going. Then we're going to do 4, choose 1. 4, choose 2. 4, choose 3. And 4, choose 4. So what we're doing, what I'm teaching you, is just a simpler, a quicker way of expanding out terms, binomials raised to a power, instead of actually physically doing it by hand. This way will give you the right answer in about 2 steps instead of foiling out a bunch of different times. Then what you're going to do, that was the first part. Then what you're going to do is you're going to take this first part of the term, so in this case it's A, and we're going to write it in parentheses for all of them. Now if you notice, what I showed you before was how that first term actually has an exponent that's raised to this power. It has an exponent that's raised to the 4th power. But then as you go along, it decreases. So it goes 4, 3, 2, 1, and 0. But what you weren't able to see is that that second term right there actually does the opposite. It's going to start at 0 and then go 1, 2, 3, 4. So it's actually kind of cool to see that. So what you're going to do is you're going to write that second term, the 3 in parentheses, and you're going to, instead of starting at 4 and going down, you're going to start at 0 and go up. Now, what I do want you to notice is that I'm only writing a 3 inside those parentheses, not a negative 3, and that is because we already took into consideration the fact that the signs were changing because of the negative sign right there. So after you make those signs change, you don't have to write a negative 3 in those parentheses, you just have to write a positive 3. So the first term starts at the highest power and goes down, 4, 3, 2, 1, 0. The second part, the second term in the binomial, starts at the lowest power, 0, and works its way up. So that's exactly what your term is going to be. Now all we have to do is simplify it, which is kind of like the easy part. 4, choose 0 is equal to a 1. So this first term right here is a 1 times a to the 4th, and then anything raised to a 0 power is just another 1, minus 4, choose 1. You could use Pascal's triangle at this point to figure it out, but I'm going to use my calculator. 4, choose 1 is a 4, a to the 3rd, 3 to the 1st power is just a 3, and we're going to have to simplify that. We're going to have to multiply those numbers together. 4, choose 2. I think that's a 6. Yep. 6, a squared, and then 3 squared is 9. Minus 4, choose 3. Well, if you're noticing the pattern, and that was the middle term, if this was Pascal's triangle, that means that this coefficient would be a 4 again. Let's just double check. 4, math, 4, choose 3, enter. Yep, that's a 4 again, so you could use that pattern. You don't have to do all of these out. A to the 1st power, 3 cubed is 27. Yeah. 4 to the 1st, that's the exact same thing as 4 to the 0, which was a 1. A to the 0 power is another 1, and 3 raised to the 4th power is 81. So last step, I'm going to go through and simplify all this. 1 times 1 is 1, so this is just a to the 4th. 4 times 3 is 12, a to the 3rd. 6 times 9 is a 54. A squared. 4 times 27 is 108A plus 81. So that's pretty cool. You can use that pattern that I just explained to you to set up what all of the terms are going to be if you expanded this. The first thing that you do is if it's raised to the 4th power, you're going to draw out 5 lines. Then you're going to do combinations first. You start out with the 4. 4 choose 0, 4 choose 1, 4 choose 2, 4 choose 3, 4 choose 4. Then you're going to write the first term and the second term, the A and the 3, both in parentheses. The first term A starts at your highest power and counts down. The second term B, or in this case 3, starts at 0 and counts up. 0, 1, 2, 3, 4. And then all you have to do is use your calculator and simplify it. Alright, so I'm going to leave that to you to do, to practice on your own. So let's see if you can go ahead and expand that. But also the kind of questions that you might see is find the 4th term of that expansion. So instead of having to write out all 6 of them, 1, 2, 3, we're really more concerned with that 4th term, 5, 6. So what I want you to do is in your head think about this. Okay, instead of writing it all out, because instead of writing it all out, we're really only concerned with this 4th term right here. So there's a positive sign in between, so I know all my signs are going to be positive, so this is going to be positive. The first part is the combination, so because that's a 5, you would do 5 choose 0, 5 choose 1, 5 choose 2, 5 choose 3, 5 choose 4, 5 choose 5, but we're not writing those. The second part, I'm going to write the 3x in parentheses and the 2 in parentheses. Now remember that this first term over here would start at its highest exponent, so it would start at 5. 4, 3, 2, 1, 0. And then the second term right here would start at the lowest, 0, and go count up, 0, 1, 2, 3. So instead of writing it all out, I'm really only concerned with this 4th term. Now I can simplify. 5 choose 3 is a 10. Now this is just a little bit confusing because 3x squared is not 3x squared. It's 3 squared times x squared. You have to kind of distribute that 2 to both of them. So 3 squared is 9x squared. And then 2 raised to the 3rd power is an 8. So in order to simplify this whole thing, it's 10 times 9 times 8 gives me 720 x squared. Alright. Find the middle term of the expansion. Well, you would draw out 7 lines and you would do the 4th term yet again, just like what I just did. And then this is homework number 574. Homework number 114. Alright, so I'm going to stop this and start another video for you. If you have any questions regarding that, you are more than welcome to ask me. Okay?